Regardless of the reaction order, there must be a certain amount of time it takes for a reactant to go to half of its original concentration. This is called half-life. And for each type of reaction, each order of reaction, zeroth, first, or a second order reaction, there's a formula for each. Let's take a look at each of these formulas and explain them a little bit. So for a zeroth order reaction, the half-life is simply equal to the original concentration of that reactant divided by 2 times the rate constant. Fine. So the half-life gets shorter as the reaction progresses and the concentration of the reactants decrease. Sure. For first order, mathematically this comes out to 0.693 divided by the rate constant. We don't need to know anything about the concentration of that reactant. It's independent. Time required to consume the half-life is the same regardless of the concentration for a first-order reaction. Kind of interesting. And a very important point for AP Chemistry is it seems to happen a lot that somewhere in the question they mention nuclear decay. Right away you should know that nuclear decay, even though it's not really on the AP test, it is a first-order process. So when you see nuclear decay, know that that's the half-life right there, since it's a common problem. And if it's a second-order reaction, we have the half-life equals 1 over the rate constant times the original concentration of that reactant. It gets longer as the reaction progresses, since it's 1 over, and the concentration of the reactants decrease. Each successive half-life is double the preceding one. So you can plug these in and come up with answers. By the way, I want to mention that do you have to memorize these or not? Any AP student should be wondering that. So I went to the trouble of finding the green sheet, if you will, and I do have that here, so bear with me. There it is. Let's blow that up. And you can see that kinetics. Boy, they don't give you much of all the stuff you need to know. They do give you the half-life for a first order one, but that's it. So, take-home message. Better memorize those 3 formulas. I mean, you don't have to memorize first order, but you do have to memorize the other ones. Also note that there's lots of formulas in kinetics, and they really don't give you many at all. So, in another slide, we'll take a look at what you need to memorize and don't memorize for kinetics. I've summarized all of the formulas in a subsequent slide. Okay, that's a little bit about half-life.